All right, let's go ahead with part 2 of the review packet. For the problem above, find the expected value and the standard deviation of the number of rainy days. Use the formulas given in class. Well, our expected value is going to be equal to n, which is the number of days, times the probability of that thing occurring. And this is talking about the number of rainy days. So just remember that we are talking about the number of days is 3, right? 3 days. 3 days. And we're talking about also the number of rainy days. So rain is 0.3. So we're going to have 3 times 0.3, which is going to give us 0.9 rainy days. So we should really expect to have about 1 day, a little less than 1 day of rain. Okay, now what's the standard deviation? Well, that formula is a little bit different. That's the square root of n times p times q. And remember, p would be equal to that 0.3 because that's the number of rainy days, and q is going to be equal to the other probability, in this case, no rain, so that'd be 0.7. So it's going to be still 3 days for n times 0.3 times 0.7. And that's going to give me 0.7937 days. And that's our standard deviation, meaning that we can expect from our average here that it's going to be kind of plus or minus that 0.7937. All right, number 10, there's an 80% chance that Eduardo is late to any given class. Using the binomial distribution table below, what's the probability that he will be late at least 12 times to the next 16 classes? Well, at least 12 means that we include that 12. All right, and we're going to add up all these values. So adding those all up, I get 0.798, or you can say that's 79.8% chance that he'll be at least 12 times late to his next 16 classes. Way to go, Eduardo. All right, number 11, Veronica decides to do a raffle to raise money for the yearbook. She sells 1,000 tickets for $10 each. First place prize is $2,000, second is $1,000, and then there's 3 third place winners for $500. What's the expected value if you purchase 1 ticket, and what does this mean about your decision to buy a raffle ticket? Well, we've got to set up our table, the V, the P, the V times P. So what's the value of winning first place? Well, that's $2,000. What's the value of winning second place? That's $1,000. And the value of winning third place is $500. Since there's only one winner for first place, the probability of winning is 1 in 1,000. And I got that 1,000 because she sells 1,000 tickets, right here, sells 1,000 tickets. Again, there's only one second place winner, so it's going to be 1 out of 1,000 that she's going to win, that someone's going to win that. But there are 3 winners for third place, and assuming that we're all putting the tickets back in, this is going to be a probability of 3 over 1,000. So multiplying that through, we get across, We're going to multiply across here, and 2,000 times 1 over 1,000 gives me 2,000 over 1,000. Here we get 1,000 over 1,000. And then here we get 1,500 over 1,000. Adding those all up, and remember this is our symbol for sum, V times P, summing those all up, we get 4,500 over 1,000. And that is equal to $4.50. So, what's the expected value? Well, you have to do how much it costs. Where is that? How much it costs right here. We've got to subtract that, $10 each. We've got to subtract that from our $4.50. So $4.50 minus $10 gives you a negative $5.50. So you should expect to lose $5.50. You could also say something like, for the $10 you spend, you could expect to win $4.50. That would be fine too. But I like to say you should expect to lose $5.50. All right, so this is really your expected value right there. And what does this mean about your decision to buy a raffle? Well, this means that you really should expect to lose. You should expect to lose. Determine the cost of the ticket that would make this raffle fair. Well, you would want an even breakout, so you would want the same price as this $4.50 right here. So you would do $4.50 would be your fair ticket price. Because basically, like, you wouldn't win any money, but you wouldn't lose any money. Doesn't make any sense for that to be the actual cost of the ticket, because the person doing the raffle would lose money. But yeah, it is what it is. So that would be the price to make the raffle fair. Okay, now for this following thing, I'm going to create another video just to remind you how to find the standard deviation of a data set on your calculator. But for now, you should know that you get 2.9 cats. And again, if you didn't get that, please make sure you watch the video on how to find standard deviation and Tukey's 5-number summary using your calculator. You will be allowed to use your calculator. So in addition to that answer for your calculator, you also get a min of 1, a max of 10. You get Q1 is 2.5, you get Q3 is 6, and you get your median is 3. And again, watch that video if you're not getting those answers. All right, finding the range is going to be max minus min. So in this case, we're going to have 10 minus 1, which is 9. So that's our range. But our interquartile range is actually Q3 minus Q1. In this case, that's going to be 6 minus 2.5, and that gives me 3.5. All right, determining if there are any outliers in the data, what you would do there is you would do Q1 minus 1.5 times the IQR. Well, just use the values we got above. Q1 was 2.5, and then it's always going to be 1.5 there. IQR was 3.5, and here I get a negative 2.75. So less than negative 2.75 would be an outlier. But of course, we also have to do the one that's adding. So we would have to start with Q3 and add 1.5 times your IQR. So my Q3, remember, is 6. And we're adding, again, 1.5 doesn't change, but our IQR is still 3.5. And that's going to give me a value of 11.25. So more than 11.25 would be an outlier. Oops, that's going to bother someone. All right, Miss Sorensen has 2 cats. What's her z-score? Well, remember, z-score formula is equal to x minus x bar over standard deviation, which is going to be equal to 2 is the number of cats I have, minus the average, which, remember, did we find that at all? Looks like we didn't find the average, but it should be in your graphing calculator. If not, you can just add up all these values and divide by the total number. And so I get a average of 4.22. And I'm going to divide that by 2.9. That's our standard deviation, which we found right here. And we do the math. Make sure you keep parentheses if you're going to do this all at once in your calculator. And then you press enter, and you get a negative 0.7655, which is proof that I need more cats. All right, that's it for these 2 pages, okay? And I'll see you back soon for the last 2 pages. Don't forget to watch that calculator video if you need it.